morning children. Let us continue our class about oxidation and reduction with another definition, that is in terms of electrons. For example, if you consider the elements like sodium. Sodium, in order to attain stability, it has to lose one electron. So sodium loses one electron and forms Na+. Or if you consider magnesium, magnesium generally loses two electrons and produces Mg2+. Or if you consider aluminium, it generally loses 3 electrons and produces Al+3. Is it clear, children? So this process which involves removal of electrons, the process in which an element loses electron is termed as oxidation. Is it clear? The process in which an element loses electron is termed as oxidation, and the element or the element which undergoes oxidation is termed as reducing agent. Let us consider chlorine. You know that chlorine's configuration is 287. So in order to attain stability, chlorine always shows a tendency to gain one electron. So chlorine will gain one electron and form Cl-. Or oxygen has a tendency to gain 2 electrons and form O2-. Or nitrogen has a tendency to gain 3 electrons and form nitrogen N-3. Is it clear? So this process which involves gaining of electron is termed as reduction. And the element which undergoes reduction is called oxidizing agent. Is it clear, children? So we define oxidation and reduction in terms of electrons also. So yesterday we have studied that oxidation is the process which involves addition of oxygen or any electronegative element, or it is the removal of hydrogen or any electropositive element, and today we have seen that it is the process which involves removal of or losing of electrons, and the element which undergoes oxidation is always termed as reducing agent, and reduction is just the opposite process of oxidation, and the process where oxidation and reduction takes place simultaneously, that is side by side, is termed as redox reaction. Is it clear, children? Now we have to study about one more definition about oxidation and reduction, but before that let us pass through a new term called oxidation number. So first let us study about oxidation number. Oxidation number, as the term indicates, it's a number. Is clear? It is a number. And what is the speciality of this number? Let us see with the help of an example. First you consider the compound KMnO4. Okay. Does it carry any charge? No. Now from this, if you want to find out the oxidation number of Mn, oxidation state of Mn, remove the other atoms from this molecule in the form of ions. So whatever be the charge, the residual charge Mn will get, or it appears to get, when all other atoms from this molecule will be removed in the form of ions, is termed as oxidation number. Is it clear, children? So oxidation number means the number, it is the charge possessed by an atom when all other atoms from that molecule will be removed in the form of ions. Okay, so once more I will define it. It is the residual charge possessed by an atom, or the charge appears to possess by an atom when all other atoms from the molecule will be removed in the form of ions. Is it clear? So suppose from this molecule, if you remove potassium as K+, or oxygen as oxide O2-, 4 oxide ions are there. Now whatever be the charge left for this atom is termed as oxidation state or oxidation number of manganese. Is it clear, children? So if you remove these ions, then you can see that the total charge possessed by potassium is +1 and that of oxygen is 4 into -2, it is -8. Therefore Mn will get a charge of +7. Is it clear? We will do more examples, then it will be clear to you. But at least at present, have you got the definition oxidation number? So oxidation number is defined as the residual charge an atom will get or appears to get when all other atoms from the molecule will be removed in the form of ions. Now, before going to find out how to calculate the oxidation number, let us pass through certain points. First point, we can say that in the elemental state, the oxidation state of an element will always be equals to 0. In the elemental state, the oxidation state of any element will be equals to 0. That means if you consider chlorine, the oxidation number is 0. Or if you consider sulfur, the oxidation number is equals to 0. Whatever be the element, if it is in the elemental form, oxidation state or oxidation number will be considered as 0. Second one, we can say that the oxidation number of a molecule will be equals to 0. The oxidation number of a molecule, that is the sum of the oxidation number of different atoms in this molecule will be equals to 0. Or if it is an ion, the oxidation number will be equals to the charge. Or if it is a radical, the sum of the oxidation number of different atoms in this radical will be also equals to the charge. Is it clear? If it is a neutral molecule, the total oxidation, the sum of oxidation number of different atoms will be equals to 0. If it is an ion, it is equals to the charge. And if it is a radical, the oxidation number will be the sum of the oxidation state of different atoms in this radical will be equals to the charge. Is it clear, children? Then we can say that oxidation number of, if you consider the first group elements will be +1, second group element will be +2, or third group element will be +3, or if you consider 16th group element, we can consider it as -2, 17th group element -1. Is it clear, children? And here certain exceptions are there. If you consider oxygen, generally oxygen shows the oxidation state of -2. Okay, but in peroxides like hydrogen peroxide or sodium peroxide or barium peroxide, oxygen will shows the oxidation state of -1. That is, in peroxide, oxygen shows the oxidation state of -1. Just keep it in your mind this. Okay, and in OF2, you know that fluorine is the most electronegative element. Okay, this you are studying in chapter 3. So you know that fluorine is the most electronegative element. Therefore, the oxidation state of oxygen in OF2 is +2. Is it clear? In OF2, oxygen shows the oxidation state of +2. And hydrogen generally shows the oxidation state of +1. But in hydrides like sodium hydride, we can say that it will be equals to -1. Is it clear, children? That is about the general points to discuss before finding out the oxidation number. Now can we try to find out the oxidation number of certain elements? Okay. So let us consider some examples. For example, if you want to calculate the oxidation number of Mn in MnO4 minus. So the first point, you know that the total oxidation number of different atoms in this radical is equals to -1. Okay. Now let us assume that the oxidation number of Mn be X. So X plus, how many oxygen atoms are there? 4. 4 into the oxidation number of oxygen, generally it is -2 is equals to -1. Is it clear? So X is equals to +7. Okay, children. Next one you consider, that is H3PO4, and we want to calculate the oxidation state of P. Now this is a neutral molecule, so the oxidation state, the sum of oxidation state should be equals to 0. So we can say that 3, that is 3 into 1 plus X plus 4 into -2 is equals to 0. Okay, children. So X minus 5 is equals to 0, or X is equals to +5. Clear? Now let us consider one more example, Cr2O7 -2. So in this case, again what is the sum? It is equals to -2. So 2x plus 7 into -2 is equals to -2. Or 2x is equals to +12, or x is equals to +6. Is it clear, children? So can you tell me what is the oxidation state of this phosphorus? Will be equals to 0. Since it is in the elemental form, the oxidation state we can consider it as 0. Is it clear? This is how you can find out the oxidation number of different atoms. Is it clear? Or can you tell me what is the oxidation state of sulfide? Yes, it is equals to -2. Is it clear, children? Now, before winding up the class, let us see what is the difference between valency and oxidation number. Children, valency is just a number. I mean, it does not carry any sign. Is it clear? The valency of hydrogen, we can say that it is monovalent. Valency is 1. Is it clear? But when you are taking the oxidation state, you have to show the sign. it always carry the sign either plus or minus. Oxidation number can be fraction also, but valency can never be fraction. Is it clear? And valency is actually defined as the combining capacity of the element, and oxidation number is defined as the residual charge when the other atoms will be removed in the form of ions. Is it clear, children? So the main difference is that valency does not carry any sign, but oxidation state carry the sign. Is it clear? Thank you. The rest we will study in next class.